Happy learning! Today we're going to talk about applications of functions in business and economics. Okay, before we get started, we need a little bit of notation. So we're going to let P of x be the profit from the sale of x units. All right, so how much profit did you make if you sold x units? That's P of x. R of x equals total revenue from sale of x units. So revenue is how much money you bring in, and then C of x is the total cost from the sale of x units. So how much money did you spend? Our profit function is equal to our revenue function minus our cost. How much money did we bring in minus how much money did we spend? That's how much money we have left over. All right, and in general, to get our revenue and cost function, it's really not too bad. So in general, revenue is equal to the price per unit times units sold. If you sell 5 hamburgers for $10, your revenue is 5 times 10, $50. And cost has a variable cost, so the cost to produce a unit, plus a fixed cost. So, the initial setup of the manufacturing plant, for instance. That's a fixed cost. Okay, let's take a look at an example. So suppose a firm manufactures headphones and sells them for $50 each. All right, so this firm makes the headphones and sells them for $50. The costs incurred in the production and sale of the headphones are $200,000 plus $10 for each set. Okay, so they had to basically build the manufacturing plant, but the cost of materials and labor is $10 per set. What I want us to do is write a profit function. For the production and sale of X units. Okay, so try this on your own, and then once you try it on your own, unpause the video and you could watch my solution. But this really is not too bad once we take our information and just rewrite it into equations. All right, so a firm manufactures and sells headphones for $50 each. Using this information, we could find our revenue function, right? Our revenue is how much we sell the headphones for times the number of headphones we sold. So 50 times X. The costs, we have a fixed cost of $200,000 plus $10 per set. So our cost function is $10 per set plus 200,000. And now we're basically done with the problem, right? Because we know that our profit is revenue minus cost. So it's 50x minus, use parentheses, our entire cost function. And now we could clean this up. So distributing the minus, we get 40x minus 200,000. Okay? So that's our profit function. If we sold no headphones, we would be $200,000 in the red. But as we sell headphones, our profit keeps increasing by $40 for each pair of headphones that we sell. This number 40 tells us how much our profit increases for each additional headphones we sell. That's called the marginal profit. All right, so let's define that so you can have it in your notes. The slope of the profit function is called the marginal profit, which we write MP overlined. It tells us how much our profit increases from that next unit sold. Right? If we increase X by 1, our profit will increase by $40. Okay, we could define something similar for marginal revenue. And marginal cost. All right, let's take a look at an example. Suppose that the cost function all right, so suppose that our cost function is C of x equals 21.75x plus 4,890. What is the marginal cost? And what does it mean? All right, so again, I encourage you to pause the video and try this on your own. It's very easy to just watch me solve the problems, but I want you to learn, okay? So welcome back from the pause. How do we find the marginal cost? It's the slope of our cost function. So our marginal cost is the slope of our cost function. How do we get the slope here? It's just the number next to x. All right, at least when our cost function is a line, which it is. So that's our marginal cost. And how do we interpret this value? It says for each additional unit sold. Costs increase by $21.75. All right, so marginal cost or marginal revenue or marginal profit tells us how much our function increases by that next unit sold. All right, let's take a look at another example, and then we'll move on to economics. All right, so a manufacturer sells a product for $10 per unit. The variable costs are $2.50 per unit. Okay, the variable cost is just another way to say that marginal cost. Okay, the cost for 100 units is $1,450. So this includes the fixed cost. So the total cost of 100 units is $1,450. And the question is, how many units must be sold to break even? All right, this is a little bit tricky, but I have faith in you. How do we find the break-even point? The break-even point is when our profit is 0, or another way to say that is when our revenue is equal to our cost. All right, so we want to figure out when our revenue function is equal to our cost function. Well, let's just restate this problem using some functions. So a manufacturer sells a product for $10 per unit. That's our revenue. Right? Our revenue is 10 times the number of units sold. The variable costs are $2.50 per unit. That's our slope. And the cost for 100 units is $1,450. That's a point on our cost function. All right, so we have a point and a slope. So let me know in the comments, how would you write the equation of a line? If you have a point and you have a slope. If you said point-slope form, you're correct. All right, so let's use point-slope form. All right, our cost function, so this is playing the role of y in our point-slope form. So cost minus the cost component of our point is equal to our slope times x minus 100. All right, and so now we can distribute this, combine like terms. We get our cost function is equal to 2.5x plus 1,200. We have our revenue, we have our cost, we're ready to find the break-even point. So let's set our revenue equal to cost, and we'll solve. So 10x equals 2.5x plus 1,200. Subtracting over the 2.5x. Is 1,200. And now we'll divide both sides by 7.5. And we have x equals 160. All right, so once 160 units are produced and sold, this company is now, they broke even. The next unit will make them profitable. So let's now talk about supply and demand. Okay, and so basically, we're going to have a quantity axis and a price axis. And so suppose we're selling something. As the price goes up, we're going to want to make more. All right, so this is going to be our supply curve. It's going to have an increasing slope. And similarly, as the price goes down, the demand for the object is going to go up. So we're going to have a demand curve that has a negative slope. We're going to be interested in when these two curves meet. That's our equilibrium point. That's going to determine the price and quantity of some object in the market. How do we find the equilibrium point? Well, to find the equilibrium point, it's where two lines intersect. So we're going to use our techniques from solving systems of equations to find the market equilibrium point. And so let's take a look at an example. So a group of wholesalers will buy 50 dryers if the price is $200. And 30 dryers if the price is $300. All right, this wholesaler is willing to buy 50 if the price is 200 and 30 if the price is 300. And we're assuming that there's going to be a linear relation. The manufacturer is willing to supply 20 dryers if the price is $210, and 30 if the price is $230. Right, so if somebody's willing to pay more, this manufacturer is willing to make more. This kind of makes sense. Let's find the equilibrium price, or the equilibrium point for the market. Okay, and so what we want to do, let's take a look at our drawing here. We want to find a function that represents supply. We want to find a function that represents demand. And both of these functions will have price as a function of quantity. All right, so it's going to be like P equals some function of Q. And so let's start. A group of wholesalers is willing to buy. So this is our demand side. So we'll start with demand. 50 dryers at $200 each. That's a point. Quantity of 50, price of 200. 30 dryers at $300 each. That's also a point. We need to find the equation of a line that goes through these 2 points. And so how do we do that? Let's find the slope, and then we'll use point-slope form. All right, so our slope, M, is the change in price divided by the change in quantity. All right, and so we have a slope of -5. We could use either of the points to get the equation of the line. I'm going to use the first one. So our price, so this is Q, this is P. Our price minus 200 is equal to our slope, Q minus 50. All right, solving for price, we have our demand function is price equals -5Q plus 450. Let's now find our supply function. Typically, you'll hear the term demand curve or supply curve. We're going to use more advanced functions later on, but for now, lines are a good way to start. So on the supply side, we have this point, 20, 210. And we have the point 30, 230. Just like with demand, let's find the slope, and then we'll get the equation of the line. So our slope is the change in price over the change in quantity, which is 2. Using either one of these points, so price minus 210 equals our slope, quantity minus 20. And we get price equals 2Q plus 170. This is our supply curve. This is our demand curve. We need to find where they intersect. That's our market equilibrium. All right, so to find where they intersect, basically we could just set them equal to each other because we have P equals this, P equals this. They intersect when the right-hand sides are equal. So 2Q plus 170 is equal to minus 5Q plus 450. Let's bring the Q over, 170 over. 7Q equals 280, or Q equals 40. Okay, the quantity of our market equilibrium is 40 dryers. At what price? Well, we could sub that into this equation or this equation. We're going to get the same number either way. All right, so our price is 2 times 40 plus 170, which is $250. All right, so if the market would settle on the supplier supplying 40 units and selling them at $250 per unit. All right, well, let me know what you thought of today's class, and I'll see you in the next one. Bye-bye.